Hi, everyone. Welcome today to my talk on designing a scalable ML ops pipeline, also known as machine learning operations pipeline. So first, before we get into the talk today, let me first introduce myself. So my name is Victoria Lowe. I'm a solutions engineer, which means I kind of do pre-sales and technical consultant for a lot of companies, as well as for helping with integration for different products. Next, I'm also a technical writer. So I freelance for different kinds of companies in terms of writing technical tools or writing documentation. And finally, I'm also like a podcaster. So I do own a podcast at RegTech Dev. If you're interested in learning more about the tech industry without having all those like heavy technical terms or like in a more casual setting, please do check out my podcast at RegTech Dev. Finally, I'm also a WomenWhoCode leader, so I'm actually here today representing the organization that actually promotes to empower women in tech. Obviously, there's the word woman in it, but it's actually inclusive to both women and men. So if you're interested in anything, please reach out to me if you're interested in joining a community, a tech community. Next, I think I spoke to a lot of people in the conference about APIs, technology in general. And if you're kind of bored of doing that all day, feel free to talk to me about games, books, or tea as well. Like I can talk other things besides tech. So now let's get into the main topic. I know a lot of you that I spoke to during the conference. Some of you are not very fluent in ML or very understanding how ML works, how ChatGPT actually works, like what is behind the architecture of these machine learning tools. So I actually would like to introduce you first as a start, how machine learning models work. So there are three pillars in machine learning models. Basically, first you have the data. The data is used to train the model. So like for ChatGPT, it's trained on hundreds, billions and billions of text data. So data is used to train the model. And then the model itself is used to make predictions or basically generate things like ChatGPT generate text and all that. So that's the second pillar. And then finally is the code itself. The code would be about basically deploying the model where it would be or maintaining the model, monitoring its performance, and all that stuff would be all around how the model actually works. So that is the three pillars of machine learning, and we are probably going to go back to it throughout this presentation. So I'm actually a solutions engineer from the payments industry, and so I would like to first give an example. So the easiest way I can show you as an example in the payments industry is a fraud detection model. So you know how every year billions of dollars are being lost through fraudulent transactions, and how companies try to reduce these losses is actually by implementing a fraud detection system. So what a fraud detection system? It's actually, let me show you a simple end-to-end flow. So first, when the customer makes a payment, let's say you buy something online, there will be transactions, right? And there will be billions of transactions. So all these transaction data actually will be used as part of training the fraud detector model. So once a payment is executed, the fraud detector model would actually get triggered. And then from there, the model would predict a risk score. So a risk score is an arbitrary number from 0 to infinity, let's say. Basically, the higher the score, it means the more riskier the transaction is predicted to be. So the fraud detector model would predict this risk score, and then there will be an algorithm that actually kind of understands whether or not the risk score is considered risky or not. They'll have some kind of threshold, like let's say any risk score above 600, that would be considered risky. So we basically have the system to actually alert a detection, say, hey, actually this transaction might be a fraud based on, if it's over the threshold of the risk score. But this threshold is determined based on many factors, and that's part of the algorithm. So once it's detected a fraud, and that would basically make the system either hold the transaction, so prevent it from actually going through, or they would just block that transaction. So that is how an end-to-end fraud detection system works. So now let me ask you, what if the data change? What if the transaction data that's used to train the model is now not the same. Like let's say fraud methods have evolved. So now you cannot use the same old transaction data, the billions of transaction data that you have used to train this model. It is now outdated. Now fraud methods have evolved and they have found new ways to actually bypass the fraud detector model. That means that now that the data change, you have to update your model because now the model is no longer viable, is no longer accurate at predicting whether or not the transaction is a fraud or not. And so if the model has changed, that means we have to update the code as well, because that means the risk score, the way we calculate it, the way we determine the threshold would also be different. And the way we also have to deploy a new model. So everything would have changed then. So in summary, if the data has changed, that means we would have to retrain the model. And if the model has changed, that means the code would need update. And if the code has changed, the new model must be deployed. So what does this all mean? It actually imposes some challenges, which means the model performance actually starts to decay with time. It's a continuous loop, as you can see, data, model, code. These three pillars are highly interconnected, and if any of them change, the rest would need changing and updating as well, which means overall, as the model performance starts to decay, it's really hard to maintain and just keep the model reliable. And it can actually put some risk for businesses. So this is where ML ops come in. So ML ops is the practice and processes around designing, building, and deploying ML models, machine learning models, into continuous production using DevOps principle. So if any of you are familiar with DevOps principles, it basically means that we want to ensure that these models are continuously updated and continuously error-free whenever it's in production, because we want to make sure that it's always the model that's most up to date that is actually handling all these transactions, that predicting all these transactions. Going back to that fraud detection example. So now let's go back to our three pillars of how machine learning models work. So as you can see here, the data that's used to train the model itself, and the code. Now, how do we implement an effective machine learning ops pipeline around these? Because for machine learning ops, basically what we want to do is to make sure that the model is continuously updated and continuously being the best performance it could be in production. Well, the answer is actually pretty simple. We will build pipelines around each of these three pillars. So first, we have the data pipelines, which would be in charge of ingesting, validation, as well as cleaning the data. So ingestion of data would mean collecting the data from various sources. Validation would be making sure that data is actually relevant for the model and align with the business goals. And cleaning the data would require formatting the data, ensuring that it's prepared for training the model. And then we would have the machine learning model pipeline. So this pipeline actually would do feature engineering. So basically setting the parameters needed to train the model. Next is the training process itself. We would automate the training of this model, and then evaluation. So basically finding out the matrix of the model, how accurate it is, its precision, and all that. Last but not least, we'll have the code pipelines. So this pipeline would actually automate the deployment process of the model. So basically that making sure that it's available to be used and for the tool, and then monitoring the model. So anything that requires monitoring its performance as well as logging. So logging the model, basically checking for errors, checking for anything that could happen while it is being deployed, while it is deployed itself. So luckily for us, when we're thinking about how to implement all these pipelines, it sounds really overwhelming at this point, I'm sure. Luckily for us, actually, there's already tools that are actually built in order to solve this problem and in order to help you have these ML ops pipelines basically spin it up pretty fast. And so these are some of the tools that are available right now. It is quite a niche area, but it is definitely growing because of AI. So that's why today I want to introduce to one of the tools that we'll be using for the demo at the end of the session, which is Vertex AI. So the reason why I use Vertex AI is actually quite simple. I use Vertex AI because I used it for my job. That's That's the main part. But secondly, I also like how it actually covers the end-to-end process in the machine learning workflow. So all the way from the first step, data ingestion, to the model deployment and its monitoring and management. It actually covers everything, where some tools would only partially cover the process, which makes it hard because that means you have to combine with other tools if you want to automate the whole machine learning pipeline. Next is I also like how Vertex AI unifies all the Google Cloud products. If you don't know, Vertex AI is actually by Google, so it actually would have a lot of synergy if you use other Google products such as BigQuery, AutoML, and so on. Next, this would be the main reason why I like to use Vertex AI, and we will also see it in the demo that I'll show later, is that it actually helps create pipelines very easily with pre-built components. So that way you don't have to be create all these logic by yourself, but it's actually pre-built for you, which we will see later in the demo. Next is also serverless and fully managed. I like how it's actually, it helps you save time and cost on the infrastructure. You don't have to really think about, spending time to build ML ops from scratch when you already have a platform that covers everything for you. So it's actually pretty solutions focused, and you can create a ML ops pipeline very easily with Vertex AI, which I'm going to show right now. So here's the demo that I'm going to build with Vertex AI. I'm going to build a fraud detection pipeline. So an end-to-end machine learning workflow of fraud detection. So you can see actually visually how this works. So step one, importing the data. For any kind of machine learning pipelines or models, the first thing we need is the model, right? Which means we have to train a model. And where do we get data? So luckily for us, BigQuery actually have a publicly available fraud detection data that you can use. So here in this demo, I'm actually using their data in order to import it to BigQuery and use it for training. So step two, I actually trained this data. So I trained this data on AutoML, which is their very high quality machine learning engine that they can use to train these data. So after you set some parameters and then you just leave it there to train, you can actually review the model matrix afterwards. So the model matrix would be like the accuracy and the precision. At the end of this training, you would actually be able to evaluate the model and see how accurate it is and if there's any changes that you want to make to improve this accuracy. So this next step, once you have a model ready and trained, before we deploy it to production, we actually first need to have a matrix evaluation custom component. So this part is actually where the ML ops is starting to come in, is where we want to have a conditional statement to determine whether or not the model that is trained in step two is actually good enough for deployment. So we would have a threshold. So let's say we want at least accuracy to be 98%. So in step two, we determine the matrix, like let's say it's 90%. If it's below this threshold, 98%, that means it's not accurate enough for production. So by creating this conditional statement, we're actually ensuring that any models that actually made it for production and deployed for production is actually within what we defined the model to be in terms of the threshold. So we want it to be better in terms of the accuracy or some other things that we want to define. So by doing this matrix evaluation component, we can actually automate the deployment of the model, which we'll see later in the next step. So the next step is actually finally the machine learning ops part, which is we are creating pipelines all around the three pillars as mentioned before. So again, back to Vertex AI, how they use pre-built components. I really like how they already have all these ready for you. That way you don't have to code from scratch. So let's look at the first pipeline that we're going to automate is the data pipeline. So for tabular data set create op, this component actually allows us to retrieve any data set source either from cloud storage or BigQuery. So automatically, if you upload something, let's say new data, it would actually retrieve that data set source, and then it would move on to the machine learning model pipeline part, which is the AutoML tabular training job run op. So this component actually allows us to trigger the AutoML training job for this data set. So immediately, if it detects any changes or any predetermined conditions that we set it to be, the model pipeline would actually trigger this training. So it'll automatically train the model. And then next is the endpoint. So it'll also create an endpoint. So after training the model, it will create an endpoint where this model will be deployed to. And then in between the model and the code pipeline, there will be the conditional statement, as we said before in step 3, whether or not this model is good enough for production. So after, let's say, the condition has passed, the code pipeline would trigger. So this code pipeline would actually be the model deploy op. It's in charge of deploying the model based on the specific endpoint we gave it in the model pipeline. So it'll deploy the model to the endpoint that is determined. And then this is optional, but let's say after all the pipelines are run, your team wants a notification that says, hey, actually this has been completed. Would you like to take a look and all that? We'll have the Vertex notification email up pipeline, which actually allows every single member of the team or like anyone that's specified to be notified for when the task is complete. So that is the all-in-all general way of automating all these tasks in the pipelines. In an overview, we can see that it's actually top-down from all the steps that we say, data ingestion all the way until model deployment. The first would be, as you can see on top here, Vertex AI have a very visual way of showing all their machine learning pipeline, which is another reason why I like to use it. It'll show the first is the data pipeline, ingestion, validation, and cleaning. And then you go down to the middle, it will be feature engineering, training, evaluation. So it's the model pipelines that we have determined, we have set before. And then finally, if the conditional has passed, if the model's accuracy or something like that has been determined to be good enough for production, we will then move on to the code pipelines, which is deploying the model and then monitoring it and logging it. And what I like about for Vertex AI is that it actually logs every single model that has been deployed before. So it can allow you to benchmark and compare the performance of previous models that you have deployed. I think that's a really easy way to continuously improve on the model. So that's why another reason to actually like Vertex, to actually use Vertex AI. So we've come to the end of the presentation. This is an overall high-level view of how to actually implement a machine learning ops workflow. Thank you so much for listening. If there's any questions, please feel free to reach out to me. I have my website here, low-victoria.com. I have my LinkedIn as well. And be sure to check out RegTag for anything that you're interested in tech. So thank you so much for the opportunity to present. I would like to thank Apidays, the team, for actually giving me the opportunity to present. Thank you so much, and I hope to see you next time.